Article 376 of the National Electrical Code specifically addresses wireways. When dealing with conductors exiting a wireway, it's important to understand the applicable requirements for protection. There isn't a specific section that mandates a rubber gasket for conductors 4/0 or larger that are leaving a wireway. However, 376.15b and 376.15c cover the general requirements for protecting conductors. Section 376.15b addresses conductors entering a wireway from a raceway. It stipulates that these conductors must be protected by a bushing or adapter that is specifically designed for this purpose. This applies irrespective of the conductor size. This means even if the conductors are smaller than 4/0, they still need to be protected with a bushing or adapter when entering the wireway from a raceway. Next is 376.15c, which states that conductors leaving a wireway must be protected against abrasion. This requirement also applies to all conductors, regardless of size. The type of protection needed hinges on the specific conditions at the point where the conductors are exiting the wireway. For example, if the conductors are passing through a sharp edge, more robust protection might be necessary compared to a smooth, rounded opening. When 350 conductors are leaving a wireway through a 12x12T fitting, a rubber gasket could potentially provide sufficient protection against abrasion. However, it is also acceptable to use alternative methods such as a grommet or a short piece of conduit to protect the conductors. The primary objective is to prevent any damage to the conductor insulation. Consider the environment the wireway is in. Is it exposed to moisture, chemicals, or extreme temperatures? These factors could influence the choice of protection method. If the wireway is in a corrosive environment, a rubber gasket resistant to that specific corrosive agent would be advisable. The ultimate decision on whether to use a rubber gasket rests with the installer. It is crucial that the chosen method adequately protects the conductors from abrasion and complies with the requirements outlined in Article 376 of the NEC. Protection methods could include using listed bushings, applying chafe tape, or installing short sections of conduit as a sleeve. It is always better to overprotect conductors and minimize the risk of future electrical problems. Furthermore, it is recommended to consult with a qualified electrical inspector. This can help ensure compliance with local codes and the proper interpretation of the NEC requirements. It is important to properly support the conductors within the wireway and at the point of exit. This prevents excessive strain on the connections and ensures long-term reliability. The NEC also addresses the fill capacity of wireways. Make sure that the conductors within the wireway do not exceed the allowable fill, which could lead to overheating and potential safety hazards. Consider future expansion when designing the wireway installation. Ensure that there is enough space for additional conductors if needed. Maintaining proper labeling and documentation is essential for future maintenance and troubleshooting. Clearly label each conductor and document the wireway layout. When installing conductors in a wireway, avoid sharp bends. This can damage the insulation and reduce the current carrying capacity of the conductor. Use appropriate bending tools and techniques. Regularly inspect wireways for any signs of damage or deterioration. This helps identify potential problems before they become serious hazards. Keep wireways clean and free from debris. This prevents overheating and ensures proper ventilation. In summary, while the NEC doesn't explicitly require a rubber gasket for conductors 4/0 or larger leaving a wireway, the general requirement for abrasion protection in 376.15c still applies. The specific method of protection is determined by the installation conditions, and alternative methods such as grommets or conduit can be used if they provide adequate protection. Always prioritize safety and compliance with the NEC and local electrical codes. Also, if you are working in a northern climate, you should check for ice buildup or water leaks in the wireway. Firstly, ensure the wireway is properly grounded and bonded to prevent electrical shock hazards. Secondly, use only listed and approved materials for the wireway and its components. Thirdly, properly torque all connections to prevent loose connections and overheating. Fourthly, provide adequate access to the wireway for inspection and maintenance. Fifthly, train personnel on proper wireway installation and maintenance procedures. Sixthly, implement a regular inspection and maintenance program for wireways. Seventhly, address any identified problems promptly and effectively. Eighthly, document all wireway installations and maintenance activities. Ninthly, comply with all applicable codes and standards. Tenthly, consider consulting with a qualified electrical engineer or inspector for complex wireway installations. Always remember that electrical safety is paramount, and proper installation and maintenance of wireways are crucial for preventing electrical hazards.